71 and 75. Now the trick situation occurs where the number is smaller. This condition is no more true because 71 is now smaller than 75. What do? Hi everyone, welcome to my channel Code with Ease by Varsha. Today we will solve this Leetcode medium question which is called daily temperatures. These are the companies in which this question has already been asked. So what is the problem statement? We are given an array of integer which is representing the temperatures, the daily temperature, and we have to return an answer array such that the answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day, keep the answer as 0. So if this is the array of temperatures of different temperatures on different days, we have to return another array, and the array should consist of the value which will be how many days we have to wait after that current ith value to get a warmer temperature. So if 73 was the temperature and 74 is the next temperature, how many days we have to wait to get a warmer temperature? Of course, 74 is greater than 73, so 74 is the warmer temperature. We have to wait 1 day. Now from 74 to 75, same logic, we had to wait for 1 day, so 1 and 1. From 75, the temperature fell to 71. It further fell to 69 and then it fell to 72. But it rose up again at 76. So the answer for this is 4 because the index value, which is from 76 to 75, we subtract the index value of 76 minus subtract the index value of 75, we get 4. So it's flipped 4 indices away. That is why the value is 4. But what about 71? When I come to 71, it has dropped to 69 and then it has risen up to 72, which means I have to wait 2 days. That is why the answer is 2. So this is the question that we have. At every index, we have to write down. So at every index, we have to point out how many days we have to wait till we got a temperature which is greater than my current temperature. Current temperature as in the ith value's temperature. If we take a look at the other example also, here it's increasing 30 to 40 to 50 to 60. That is why you have 110. Now 0 is an important value. One more thing is, if we do not have any other temperature which is warmer than the current temperature, like for example 76, after 76 you have 73 and end of the array. So there is nothing to print as such. I mean, so if it actually fell down and the array is completed, you have to print out 0 itself. And for 73, same thing. It's the end of the array. There is no other warmer temperature. Okay, so into the whiteboard now. So what will be the approach? So if we talk about the brute force approach first, what is the initial thought process? I am over here. My current temperature is given to me. All I need to figure out is, do I have any other value in my array which is greater than my current temperature? Simple. So I have to just keep on checking if any value is greater than my current temperature. That is what I'm doing in 73. I'm checking next value. Okay, next value itself is greater. I'll take the difference of these two indices and I'll store it in my resultant array. Right? Now when I come to 74, I see the next one. I check the next one. Again, difference in the indexes. I take the value and store it in my resultant index. What about this? When I come to 75, the adjacent value is smaller. Again, I see that the next value is also smaller. Then I see the next value is again smaller. I finally reach to another value which is greater. So I had to traverse all of that to visit all the numbers in the array until I could figure out something which is greater than my current element. So what does it give us a hint of? Array traversal needs to be done, but the array traversal needs to be done in two ways. Array traversal needs to be done, but it has to be done in a nested way, which means we need to have the outer and the inner for loop. Otherwise, we'll lose track of all the values if we could do it in single traversal, right? So we first take a value, we traverse the entire array to see if there is anything which is greater than the number, then we store it. Then we move to the second value, we again traverse the rest of the array and see if anything is greater. So basically, as we have seen, this is the order of n square time complexity. 2 loops, one loop within another loop, nested loop, and we have to traverse the array every time for every single element. Very clearly, this kind of a time complexity is not required or it is not good. You will be definitely asked to optimize this particular time complexity. So how can we optimize this? What data structure shall we use to optimize this? In the sense that when we say optimize, of course, we want to do it in one single traversal only. But we also have to keep in mind that when when I'm at 75 and I'm searching the rest of the numbers and finally I come to the element which is greater, then I take the difference. So far, so good. But if I don't keep a track of these numbers which I already traversed, then I'll be losing them. In array, there is no way to do a backward traversal like we have in case of at least doubly linked list that we'll again come back and visit. So if we try to do just using array and a single traversal, just an array plus single traversal, not possible. So what do we do? The point I'm trying to make is we need a data structure where what we will do, once we are at 75, we traverse through all the elements 71, 69, 72, 76. The moment we reach 76, well and good, we'll take the difference of the index positions and we'll store it. But there should be a mechanism in which I can do a backward traversal and also get access to 72, then again get access to 69, and then again get access to 71. So the only data structure which can actually do that is a stack. Okay, it's a very bad diagram of a stack, but I'll just redraw it. These are the numbers that we have and we are going to take a stack, right? So what do we do? So first we have to remember we need to output this particular array, right? We need to output this particular array. So I'll just write the index values on top of these. Remember, we have to add the indices to the stack and not the number, because at the final calculation in the output array needs to be happening on the indexes. So first the index is empty. I will add 0. Index number 0, index is empty. Next, I will go to 74, index is number 1. Now we check the numbers 73 and 74, not the indexes here. We check the values. Is 74 greater than 73? If it is, what is my condition? If my current element is greater than stack.peak, what we are checking? The top. This is the top. So if this number, the current is greater than peak, then what we have to do? We have to do stack.pop. We have to remove whatever we have. Let's store it in some index. And at that particular index, whatever we remove, that particular index's value is going to be the current element's index, current I minus whatever you store over here, the IDX, whatever you popped. So index to index comparison. So you're taking the index to index comparison. In the output array, where are you going to place it? You're going to place it at that position or at that index which was there in your stack right now. At that index which was there in your stack. The 0 was in my stack. At 0th position, I'll put 1. So far, so good. So we have removed 0. We have popped it. Now comes 1. So I have to push 1 also. Just this condition is for the condition where your current is greater than stack.peak. But at the end, you also have to take into consideration the new number, right? 74. So I'll put 1. That is index 1. Next, index number 2 is being compared. 75 indeed greater than 74. Same scenario like 74, 73. So again, we have to pop this. Over here, I'll put 1 at index 1. We can correlate, right? The index which we are removing, that particular index in the output array, we are updating. Now 75. So 75 is also done. So we'll put 2. Okay. Now 71. So we have index 3 to compare. So 71 and 75. Now the trick situation occurs where the number is smaller. This condition is no more true because 71 is now smaller than 75. What do? We cannot pop it from the stack. We cannot output anything in our output array also. What do? We have no other option. In stack, we have push, pop, peak. No other option. So we have to add it to our array, to our stack. So we'll add index number 3 to our stack. Now we see 69. So 69 and 71 is being compared. Is 69 greater than 71? It is not. What do? Add it to our stack. Okay. Now comes 72. Now we see that index position 5 has 72. Index position 4 has 69. Now 72 is indeed greater than 69. So we have to follow this because this is the condition which will be true. We will pop 4 out from here. And what is the difference now? The difference is 5 minus 4. If 5 minus 4 is the difference, what is the difference? 1. Where do we put it? What we removed just now at 4. So index number 4, we are going to put 1. Which means for 69, my value I've already received is 1. For 69, the warmer temperature is 1 day away. Now what do? Now I am over here. I am at 72, right? Now I'm done with 69. But I also have to take into account the older numbers, which means the moment I've got a higher temperature, it's not enough to just check the stack.peak only. I have to also keep on checking the other numbers. So how about I change this if condition to a while loop? That I will not check it just once. I will check it as long as my current element is greater than my stack.peak. As long as my current element, whichever is the incoming element, is greater than the stack.peak, I will keep on doing this pop operation. So first I check 72, 69. I'm sorted. I'm done. Now 69 is removed. It is popped. Now I will check 72 and 71. Is it greater? Yes, it is. How much is the difference? 2. So at 3 position, I'll put 2. So 71 and 72 is sorted. 69 and 72 is sorted. I'll also remove 3. Now I will check index 5 and 2. 72 with 75 I am going to check. Is 72 greater than 75? Now we see it is not. So we'll stop. Our while loop is going to exit. And 5 comes into the picture. We push 5. So from 72, now I move to 76. So index number 6. Is 76 greater than 72? Now we are talking about 72 and 76. Is it greater? Yes, it is. What is the difference? 1. At index number 5, I will put 1. Okay. Now 5 is also removed because as we know, we have to pop it out also. We have popped it. Now we check what is the stack dot peak now? 2. We check 6 and 2. Remember, this comparison is always happening with the stack dot peak. 6 and 2. What is the difference? 4. So I am done with 76 and I am done with 75. This combination 75 and 76. Right? Now what will I do? I'll add 6. Next, moving on, I have 7. So 73 and 76 is being compared. So we know that it is not smaller and we know that it's not greater. So we cannot do anything. We'll add just 7. And that's it. End of the array. So what do we have? This array we know initialized to 0 already. So 0 will already be there. So that condition where we had to put it as 0 is no longer required. Whenever that, whenever this condition will not be true, by default in that particular index will anyway have 0. Yeah, this is how we are able to solve this problem, the daily temperatures. The approach is very simple. You just have to first traverse the array. So let me just write it down. First, you traverse the array. Second, you have this while loop as mentioned here. The while condition where the current element is greater, and then you just write this particular condition from here to here, where you have to pop the element whenever it is greater, and in that particular index you have to update. And outside of this while loop, you have a stack dot push where you push your current elements index, current I. 3 lines of code, actually 4 to 5 lines, just because of the if condition and these 2 lines. But yeah, basically 3 steps. That's it. You're done with this question. So that is all about the question. The code is in the GitHub. You could find the link in the description. So thank you so much for watching this video.